So we're back for the last little bit, and this is the last little bit. So for some reason, I had this thing where I wanted to kind of save space. So I put this all on one thing, and it's right, it is to do with thin lenses, but this is a situation here. This is the lens maker's equation. And the lens maker's equation is what the eye doctors will do, because they don't do perfectly symmetrical lenses very often. So if I have a material with a known refractive index, maybe plastic, maybe glass, and I have a grinding system, so I can make different curvatures of grinding, I will always get symmetrical focal lengths. The focal length in front will always be the same as the focal length behind. But the distance of those focal lengths will depend upon both surfaces. So how do you figure this out? And you use the lens maker's equation, which is, you want to know the focal length of your lens? Well, 1 over the focal length equals the refractive index minus 1 multiplied by 1 over the radius of curvature for the first surface minus the radius of 1 over the radius of curvature for the second surface. Now, look at your lens. The first surface in a converging lens has the center of its radius behind. And the first surface for a diverging lens has the center of curvature in front. So I've got to take into account, is this radius in front of the lens or is it behind the lens? And the way you do that is down here. And R1 and R2 are positive if the center of curvature is the back of the lens, and R1 and R2 are negative if the center of curvature is at the front of the lens. So if it's there, that's a negative center of curvature, and that's a positive center of curvature. And again, I think the way to remember this is you take something that you're very familiar with, and you recognize that's R1. That's a positive R1. Agreed? Center of curvature is in the back of the lens. So that's a positive R1. And there's R2. And that's going to be a negative R2. So if you take something you're very familiar with, like the typical converging lens, and you commit to memory that R1 is positive and R2 is negative, you can kind of figure out the rest from there. Or you remember this, one way or the other. Okay? So, let's do an example. So we'll say that N is equal to, let's make our lenses out of diamond, why not? So that's 2.4. Yeah? And let's say that we have a diverging lens. And let's say this is 3 centimeters. And let's say that is 2 centimeters. So, which is R1? Is it this guy, or is it this guy? Which is R1? R1 is the radius of the first surface you come to. So that's R1. And is that a positive R1? Is that a positive 3 or a negative 3? It's in front of it. So look at the system. It's in front of it. Let's go here. R1 is positive if the center of curvature is at the back. It's negative if the center of curvature is at the front. So that's going to be minus 3 centimeters. This guy here is R2 equals positive 2 centimeters. So we get 1 over f equals n minus 1. What was it? 1 over r1. Was it plus or minus? Minus 1 over r2. Is that right? I do this so rarely that I've always got to double check myself. So this will be 2.4 minus 1. 1 over minus 3 minus 1 over plus 2. 1 over f equals 1.4. Let's have a look. That would be minus 2 over 6 minus 3 over 6, which equals 1.4 times minus 5 over 6. So 1 over f is equal to 5. That's going to be 9. 1.4 times 5 is 9, I think. 5 4s are 20. 5 1s are 5. That's 7, isn't it? Yeah, 7 minus 7 over, that's a 6 on the bottom, which equals minus 1 and 1/6. 1/6 is going to be 1...
0.85.
No, you give me the final answer. You give me the final answer?
It's 0.85.
Yeah, you're giving me the final answer. Yeah, you're giving me the final answer, 0.85. Okay, 1.1 something here. And that's going to be in centimetres. Diverging, oh yeah, negative value. That makes sense. So not bad. Final bit. Not bad. Paperweights, where the object is inside the lens or inside a body of water or something, yeah? Don't care about it. We've done enough, okay? No, it's there. You know, you've just got to learn the things, but I wouldn't ask you about that. Okay. So we'll end it on our lens maker's equation, okay? Let's stop that.